Hello everyone, I am Chinmay P, studying in CSE 4th Sem. Today I am discussing about solution space trees. What is solution space tree? Solution space trees will offer graphical representation of a possible solution. They are crucial for combinational optimization problems in ADA. These trees will help to visualize and explore complex solution possibilities. They are commonly used in AI, game development, and operation research. A solution space. Solution space is a set of all the potential solutions. Each node will represent a partial or the complete solution. The root node will be the initial state and the leaf nodes will be the final solution. Edges will represent the decisions or the steps towards the solution. Here we got a proper figure about the solution space tree. How to construct the solution space tree? First, we'll start with the root. We'll begin by establishing the initial state as the root node. Usually, if they give us a set of element, we'll start the initial state as 0 and then we'll keep on including and excluding. So we'll start with the root. Then we'll expand each node by including and excluding all the elements in the set. In the subset problem, I'm telling about the subset problem. Here we'll generate the child nodes based on all possible actions are done. And third one is pruning the branches. We'll do pruning to eliminate the infeasible or suboptimal paths early on. We don't want those nodes which are not able to be a most optimal solution. So the pruning is a very important technique. How to solve the subset sum problem? Subset sum problem will involve finding a subset of numbers that sums to a target value. Here we'll be given a set of values or the elements. We should find a subset which will give the sum as the target value. Here it involves the tree will represent including or excluding an element. Here for instance we have taken an example that is a set 1, 2, 3, 4, 5 and the target element is given as 7. Here I have tried to write the solution space tree. The initial state I have taken as 0 and left side of the tree I have added the first element of the set, that is 1. And the second, to the right side of the tree I have excluded the first element, so I have kept it as 0. Then the second level, to the left subset, to the left tree I have added the second element of the subset, that is 2. 1 plus 2 I got 3, so I have written in the left tree. So the right side and I will exclude the I2, that is item 2, so the 1 will remain as it is. In the same way I'll continue for both sides of the trees. So as we keep on moving downwards, we'll find the target element as 70. At last, we'll find the 70 and also the subset will be find out by taking all the elements that are included in the tree. Finally we'll get a subset which will give the sum as the element 7. So the 7 is a target element. So until we get 7, we should continue the subspace tree. So the steps are given here. Element 1 will include or exclude. Then again element 2 will go include or exclude, and element 3 include or exclude. So based on the number of element that is present in the set, will include and exclude. The tree will be more bigger because we have taken 5 elements. So until we get the target as 7, we'll continue the including and excluding of the elements. Searching the solution space tree. The solution space tree will represent all possible decisions or the configurations of the problem. So the way you search or traverse this tree determines how you find the solution. Here we have two methods, that is DFS and BFS, depth first search and breadth first search. What is depth first search? It explores one branch completely before moving to others. It is a simple to implement and it finds any solution very quickly, and it is memory efficient for deep trees. It will go as deep as down one path before backtracking. It is implemented using the recursion or stack. Natural fit for backtracking algorithm. Example subset sum and also endpoint is also done using DFS. Some of the properties are the structure will use stack or recursion, memory usage will be low for DFS, and it is suitable for early goal discovery. and it is common in subset problems, permutations, in queens, and also Sudoku as we all know. And the second type is breadth first search. What is breadth first search? It explores all the nodes at one level before progressing. It will guarantee finding all the shortest path if applicable. It will use more memory, but it find more optimal solution. Here BFS will explore all the nodes at current depth before moving to the next level. It will finish all the nodes that is adjacent to the particular node before moving to the next node. And it is implemented using the queue. The DFS is implemented using the stack, and the BFS will be implemented using the queue. The less memory efficient for deep trees, and the structure will use is queue. Memory usage will be high for BFS, and it is suitable for finding the shortest path level order solutions. And it is very common in puzzle solving, that is 8 puzzle, and also shortest path in the graph. Pruning. What is pruning? It is in a solution space tree. Pruning means cutting off the branches of the tree that will not lead to a valid or better solution. It is a critical optimization used in the backtracking and branch and bound algorithm. In backtracking and branch and bound algorithm, we'll use this pruning technique in order to avoid some of the branches which will not lead to the solution. So the main goal of pruning is it will avoid exploring the unnecessary or invalid parts of the solution spaces. It will save the time and it will save the resources. So the pruning techniques are here I have mentioned bounding. It will estimate the cost to reach the solution. If the estimate will exceed the known best, we'll prune the branch. It should not exceed. If it exceeds, we'll prune that. The second one is constraint propagation. Apply the constraint to reduce the search space. We'll put some constraint. Constraint is nothing but a restriction or some condition in order to reduce the searching space. For example, prune if the current sum will exceed the target. As we given in subset problem, we'll give a target. If it exceeds the target, then we'll prune that branch. And a diagram is representing the pruning technique also. And basically pruning in the solution space tree is nothing but each node will represent a partial solution. So each path down the tree will represent series of decisions. Here the pruning means it's not exploring the certain paths if they violate the constraint, if they are suboptimal, if they repeat previously explored configuration. We'll follow these three. We'll not explore if they are in these three constraints. If they're violating the given constraint, or if it is suboptimal, not a best solution. And third one is they repeat previously explored configuration. There are actually different types of pruning. We have seen only bounding and constraint propagation. There is another duplicate pruning and also complete pruning, etc. The main example is a subset sum problem. So this is already mentioned in the previous slide. Advantages of using solutions based. Here I have mentioned only 4. The first one is visualization. It is easy to understand the solution process because it will be visually broad, will represent using trees, so we can understand more efficiently. And the second one is systematic exploration. We'll make sure we'll get all the possible solution we consider. All the possibilities will be considered. We'll not leave anything because we'll continue the tree until we get the target. So we'll get all types of the solution. And the third one is flexibility. It is adaptable to various problem types. We can use the solution space tree for different problem types. So it is flexible in nature. And the fourth one is pruning. If we prune, so it will reduce the search space and also it will improve the efficiency. So the space will be reduced. And some of the other are systematic exploration will be done. Systematic exploration of all the possibilities will be done. It will organize all the potential solutions in a structured way. not in an unstructured way. Each path from the root to the leaf will represent unique set of decision. It will not repeat because we'll prune it before doing. So the example is a subset sum problem. Each path will give you the unique subset. We'll get the target element in a maybe we'll get 3 times, but all the 3 times we'll get different subset as a solution. So the another way it will enable pruning, it is a main advantage because it reduces the space that is required. It will improve the efficiency and it also reduces the search space as I do. It will save the time and also computational effort. And it will support the backtracking algorithm. So the natural foundation for the recursive or the backtracking approach is the solutions-based. You can move forward deeper into the tree or backtrack if a branch fails. For example, in n-queen Sudoku permutation and graph coloring. So, at last, I'll just conclude about the solution space tree. Solution space tree are effective for solving the combinatorial problems and they'll combine the DFS, BFS and pruning for getting most optimal result. ADA will provide excellent support for implementing these structures. They are an essential tool for the algorithm design and optimization. The solution space tree it is a powerful and essential concept in the algorithm design, and it particularly that we can say in backtracking and combinatorial problem solving. It will enable systematic exploration and it will support the pruning. It will make backtracking efficient, problem visualization. In short, we can say the solution space tree is not just a visual tool, it is a strategic framework that improves the efficiency, clarity, and also effectiveness of solving the complex problems like subset sum, n-queens, Sudoku, and many more. So solution space tree is useful in all different ways. Here I have given master trees. We'll understand their structures easily using solution space tree. We'll apply algorithm. We'll use DFS, BFS, and pruning, and we'll utilize ADA here. It will implement with the language. ADA will give a great support for the implementation of these type of solution space trees. Thank you.